Okay, good morning, girls. Myself Ranjitha D Assistant Professor from the Department of Mathematics, and today's topic is Statistics 1 Correlation. So, comes to the introduction of the correlation. Now, according to the definition of correlation is a statistical device which helps in analyzing the covariation of the two variables, and it is study of interdependence between the two variables. That means if I take two variables is said to be correlated when they tends to vary either in the same direction or in the opposite direction. If the variation of one variable is accompanied by a definite variation in the other variable, then two variables are said to be correlated. For example, there exists a relation between the age of the husband and also age of the wives. Or if I take one more example, increase in the rainfall up to a point and also production of paddy. There exists a correlated between these two variables. Next is when the variable x and y are correlated, there may be three types of relation. First one is if x is a cause and y is a effect. Second one is if x is a effect and y is a cause. And third one is x and y are the effect of the some causes. For example, rainfall and also yield of the paddy. In this, rainfall is a cause and effect is production of the paddy. Second one is price and effect. In this, price is an effect and demand is an cause. And come to the third example, yield per acre of the rice and also tea are both are the effect of the rainfall. Next, there is a definition between causation. A cause and effect relationship between two variables is said to be causation, and also the example is the production of price of electronic goods shows a causation. Here an increase in production cause a decrease in price. Next, come to the uses of the correlation. What are the uses of the correlation? Correlation helps in analyzing the measuring the relationship between the variables. For example, a relation between price and also demand, and income and expenditure, income and savings. Second uses is it is found out that two variables are closely related, then we can estimate the value of one variable using the value of other variables, and also help in the regression analysis. And come to the third uses of the correlation. Correlation analysis helps to analyze the economic behavior, for example wages and also the level of inflation, saving and the rate of the tax collected, etc. Next, come to the fourth uses, the importance of the analysis and understanding the relation between the two or more variables is increasing day by day with the development in the field of the social science. For example, to study the relation between the smoking, also lung cancer, and also the number of road accidents, and also the sales of the vehicles, etc. These are the uses. Next is types of the correlation. We have different types of correlation. First one is positive and negative correlation. What is this positive and negative correlation? If the variables varies in the same direction, that means if both variables increases or decreases together, then the correlation is said to be positive, or another name is direct. For example, height and weight of a group of a person. Next is negative correlation. If the variables varies in the opposite direction, that means if one variables varies in if one variables increases, then other variables decreases, then this correlation is said to be negative. Another name is inverse. Example for this negative correlation is sales of a woolen garments and also atmospheric temperature. And second example is production and price of the vegetable. If the production increases and the price of the vegetable decreases, that is a negative correlation. Next, come to the simple, multiple and partial correlation. What is this simple? The correlation analysis determines the degree of the relation between the variables. It refers to the technique used in measuring the closeness of the relationship between the two variables. That means the correlation may be simple, multiple or partial correlation. This simple correlation means this simple correlation concerned with the related variation between two variables, and the multiple and partial correlation concerned with the variation among the three or more variables. In multiple correlation, three or more variables are studied simultaneously, but in partial correlation we recognize only two variables, but we consider more than two variables to be influenced each other. The effect of influencing the variable being kept constant. That means here in the partial correlation we will take only two variable correlation and keeping the other one variables as a constant. Next is non-correlation. What is this non-correlation? If the two variables do not show any associated variation, then they are said to be non-correlated. For example, purchasing the power of money and atmospheric temperature. Here there is no relation between purchasing of the power of money and also the temperature. And second example is sales of the umbrella and sales of student notebook. This is the correlation, non-correlation. Next is perfect correlation. What is this perfect correlation? If the variables varies in the same proportion, then correlation is said to be perfect. That means the variables shows exactly linear relationship between the two variables. Then we can say this as a perfect correlation. Perfect correlation may be positive or negative. Correlation is perfect positive when the variations are in the same proportion and also in the same direction. For example, 10% increase in x leads to 10% increase in y. That means here 10% increases in x, which also increases the 10% increases in y. And second example is considering the table, that is x and y vices. X is running from 1, 2, 3, 4, and y also increases from 5 to 25. Next is correlation is perfectly negative when the variations are in the same proportion but in the opposite direction. For example, 5% increase in x leads to 5% decrease in y. Here one is increasing, another one is decreasing. Therefore it is perfect negative correlation. Next we are considering one more table, that is x and y. Considering a table which consists of x and y. X varies from 1 to 5 and y also varies from, here y is decreasing. X is increasing from 1 to 5 but y is decreasing from 20 to 12. That means when x is 1, y is 20. When x is 2, y is 18. When x is 3, y is 16. When x is 4, y is 14. When x is 5, y is 12. Next, in method of studying the correlation. What are the methods of studying correlation? Here we have three methods. First one is scatter diagram method. Second one is Pearsons coefficients of correlation. Third one is Pearson's coefficients of correlation. So we will take the scatter diagram correlation. This is a non-mathematical method of measuring the correlation. What is this non-mathematical method? Here we will not use any formula or any calculation to find the correlation between x and variables, but here we will take a graph. That means when two variables are plotted on a graph by taking two variables along the two axes, either in x and y axis, a set of scattered points will be obtained on the graph. It is called the scatter diagram. So we will call this method as a non-mathematical method. And the scatter diagram is a graph which shows the degree of relation between two variables. Usually these related variables are the points on the scatter diagram. Will have the direction. The direction can be seen by drawing a line close to a plotted points on a scatter diagram. Depending on the direction of the line, correlation will be studied. Okay, if I consider this diagram here, see this scatter points are running from lower left side of the x-axis to the upper side. So scatter diagram is a graphic device for finding the correlation between the two variables. One variable is normally an independent variable, or the time is plotted on the horizontal axis. This is also called a predicting variables. When the points do not form a band, they are scattered in all directions. It indicates the degree. There is no correlation between the variables. In the case of perfect correlation, the points will be on a straight line. This method is mainly used when we are interested in finding out whether the correlation is whether there is a correlation, and only in getting a rough idea about the nature and degree. So these are the different types of correlation using this scatter diagram. First one is perfect positive, since it is running from left side of the bottom to the right side of the y-axis, and this is the negative correlation, perfect negative correlation, and this is the high degree positive correlation. This is high degree negative correlation, low degree positive and low degree negative, and this is no correlation. Next is lines of best fit. What is this lines of best fit? A line that is drawn to pass as close as possible to all the plotted points on a scatter graph is called the lines of best. Here we have drawn a line this line is passing through all the points. It is trying to pass through all the points. If it passes through all the points, then it is a high positive correlation. If it is not passes through all the points, then it is low positive correlation. If there is we can't draw any line between these points, then it is no correlation. And next one is high negative correlation, means here it is running from right side to the left side to the right side. So next is merits and demerits of this scatter diagram. What are the merits? It is simple and non-mathematical methods of studying a correlation between the variables. Second one, it is not influenced by the size of the extreme items, whereas the most of the mathematical methods of finding the correlations are influenced by the extreme points. Third one is making a scatter diagram usually is the first step in investigating the relationship between the two variables. Next is demerits. By applying this method, we can get an idea about the direction of the correlation and also whether it is high or low, but we can't estimate exact degree of correlation between the variables. In this scatter diagram, we can find the direction of the correlation between x and y, but we can't exactly estimate the degree of correlation. Therefore, we will move on to the next method. Before that, we will solve one problem on a scatter diagram. First one is draw a scatter diagram and conclude about the correlation. By taking x and y variables, x variables run from 10 to 80 as 10, 20, 30, 40, 50, 60, 70 and 80. Similarly, y corresponding to 10 is 25, and when x is 20, y is 20, when x is 30, y is 25, when x is 40, y is 35, when x is 50, y is 40, when x is 60, y is 35, when x is 70, y is 50, when x is 80, y is 45. Next, draw a scatter diagram for the given data. So to draw a scatter diagram, let us take two axes. First one is y axis and x axis graph, and make a point. Draw when x is 10, x is 10, y is 20, and when x is 20, y is 20. Like that, mark a point on a graph. Then draw a straight line. This straight line is not passing through any points, but it is very close to pass through all the points. Therefore, from this diagram we can conclude that there exists a high degree positive correlation between x and y. Next method is call Pearson's coefficients of correlation. Since we have the demerits in scatter diagram, that means it will only shows the directions of the correlation between x and y axis, and it will not help to find the exact correlation between x and y axis. We will move on to the next method of finding the correlation, that is KPCOC. Another short name is KPCOC, and full name is call Pearson's coefficient of correlation. What is this call Pearson's coefficients of correlation? Of the several mathematical methods of measuring the correlation, the Pearson method, popularly known as Pearson's coefficient of correlation, is most widely used in practice. This coefficient of correlation measures in one figure the exact degree of correlation exists between the two variables. Then we can write a product moment of the correlation by gamma xy is equal to covariance of x comma y by square root of covariance of x into covariance of y. In the short form, we can write it as cov of x comma y divided sigma x into sigma y, which is equal to product moment of x and y. Next is interpretation of the coefficient of correlation. What are the interpretation? If r is equal to 1, this r is represents the coefficient of correlation. So smaller. If r is equal to 1, then it is a perfect positive correlation. If r is minus 1, then there is a perfect negative correlation. If r is equal to 0, then there is no correlation. And also in generally we can write r is varying from plus or minus 0 to plus or minus 0.20, then it denotes indifferent or negligible relation. If r varies from plus or minus 0.20 to 0.40, then it shows low correlation or slight relationship. Next, if r varies from plus or minus 0.40 to plus or minus 0.70, denotes the substantial or marked relationship. If r varies from plus or minus 0.70 to plus or minus 1.0, it denotes the high or high to very high relationship. Next comes to the properties of the correlation of coefficient. What are the properties? Here we have the four properties. The coefficient of correlation is a pure number independent of the units of measure of variables. That means here we don't have any units for the coefficient of correlation. Therefore, it is a pure number independent of the units of the measure of the variable. And second one is the coefficient of correlation is not affected by the changes in the origin and scale. Third point is the coefficient of correlation cannot be numerically greater than 1. That means it should always varies from plus or minus 1. It should be greater than minus 1 and less than plus 1. The coefficient of correlation is not affected by the order. That means we can write it as Rxy is equal to Ryx. Next come to the merits and demerits. What are the merits of the correlation? The coefficient of correlation summarizes in one figure not only the degree of correlation but also the direction. Here in this method we can also estimate the direction and also the degree of correlation, that is whether the correlation is positive or negative. Next come to the limitation or the demerits. What are the limitation and demerits? The correlation coefficient is always assumes the linear relationship regardless of the fact whether that the assumption is correct or not. This is the first limitation. Next come to the second one is the great care must be exercised in the interpreting the value of this coefficient, as very often the coefficient is misinterpreted. Next is the value of coefficient is unduly affected by the extreme value. Here the value of coefficient is affected by the extreme points, and also as compared with the other method, this method takes more time to compute the value of correlation of coefficient. That means using this formula it will take more time to find the coefficient of correlation. Next is Pearsons coefficient of correlation. That means useful tips. While finding the arithmetic mean, write in the beginning to know whether the means are whole number or the fraction, so that it may help to apply the formula accordingly. Next, second useful tips is if the given values are small, then the formula was second involves the direct values. Let us see what is the first formula and what is the second formula. Come to the first formula using the actual mean method. We have the first Pearsons coefficient formula as R is equal to sigma xy by n into sigma x into sigma y. What is this small x? Small x is the difference between x minus x mean, that is x bar. Small y is equal to y minus y bar. Sigma x is the standard deviation of the x and sigma y is the standard deviation of the y series, and n is the number of paired observation. This method is to be applied when only the deviations of the items are taken from the actual mean, not from the assumed mean. And here we have the above formula can be written as R is equal to summation xy by summation x whole square into summation y square. Next come to the calculation. Here we have the few steps to be followed to calculate the R value in the first formula. First step is taking the deviation of the x from the x series from the mean value of x series and denote this by small x and square the deviation obtained, and also the summation x square, total summation x square. Next is third point is take the deviation of y series from the mean of y series and denote this deviation by small y. And fourth one is square this deviation and obtain the total summation y square. Come to the fifth step is multiply the deviations of x and y series and obtain the total summation xy. Sixth one is substituting the values of summation xy and also summation x square, summation y square in the formula, we will get the final answer. In that first problem is calculate KPCOC, that means Pearsons coefficient of correlation from the following data. We have the data as x is varying from 6, 8, 9, 14, 17, 28, 24, 31, 7, and y also varies from 10, 12, 15, 15, 18, 25, 22, 26 and 28. And first we should find what is our x bar, that means x mean value. Summation x by n. Substituting the values of the equation, that is first we need to create a table including x small x, x square, y small y, y square and summation x into y. First from the x series let us find what is summation x. It is 144 is there. So take x bar is equal to 144 by n is equal to 9. That means we have 9 pair, therefore 144 by 9 is 16. Similarly find y bar. Y bar is equal to summation y by n. Here we have the summation y as 171. Let us substitute it. So 171 in y bar. Y bar is equal to 171 by 9, which is equal to 19. So we have x bar is equal to 16 and y bar is equal to 19. Let us calculate what is small x, small y and x into y. So x is small x is equal to x minus x bar, which is equal to x minus 16, and also small y is equal to y minus y bar, which is equal to y minus 19. Let us find x square and y square and also calculate x into y. And also sum of all these x and small x, summation x square, and also summation y square, summation x into y. Here we have summation x as 144, summation x small x is 0, and also summation x square is 732, summation y is equal to 171, and also summation y small y is 0, and summation y square is equal to 338, and also summation x into y as 301. And using the values of summation x square, summation y into x into y, substitute all these values in the given formula. First formula, what is our first formula? Correlation coefficient is calculated using the equation r is equal to summation x into y by square root of sigma x square into sigma y square. Substituting all these values, we will get r is equal to plus 0.6051. Since it is a plus, it shows the positive correlation. Next comes to the second formula using the actual values. In the first formula we will use the mean value, but in the second formula we will use only the actual values, given values. So we have the formula as r is equal to summation x into y minus summation x into summation y by n. N is a number of pairs. So divided by square root of summation x square minus summation x whole square by n into square root of summation y square minus summation y whole square by n, where x and y stands for the values of the items in x and y series. So here we have one problem, that is calculate the coefficient of correlation between x and y for the following data. So what are the x values? X values run from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and y values also varies from 3, 10, 5, 1, 2, 9, 4, 8, 7, 6. So here we have the actual values formula. Therefore let us use only the x and y value, and also find out x square, y square, and also product between x and y. So at the end we should find what is the summation of x, summation of y, summation of x square, summation of y square, and also summation x into y. So here we have summation x is equal to 55, summation y is also 55, summation x square is 385, summation y square is 385, summation x into y is 321. Let us substitute all these values in the given formula, that is r is equal to, substituting all these values and simplifying, we will get r is equal to 0.224. And come to the third formula using assumed mean value. Here we have the assumed mean value formula. Okay, we will study this assumed mean value formula in the next class, girls. Okay, thank you for this.